Hello everyone, I'm Steve, and today I'm excited to introduce Aptos Test Container, streamlining integration testing with containerized environments. Let's dive into how it can improve your testing workflow for Aptos smart contracts. Before I get into Aptos Test Container, let's first review the traditional way we conduct integration tests for Aptos contracts. Typically, after writing your smart contract, you need to first publish the contract to the testnet, then manually update the contract address in your test code, and after that, you may want to process some accounts based on your testing needs. Again, manually. Once that's done, you can start testing. Each test creates a client instance that connects to the testnet, and then you proceed with writing the test logic. This approach introduces several challenges. Manual contract management is time-consuming and prone to errors, leading to inconsistencies. No reset of contract states between test runs or even between individual test cases, which can result in data races or flaky tests. To overcome those issues, we developed Aptos Test Container. Here's how it works. When running your test cases, it first spawns a local Aptos network inside a Docker container. For each test, the contract is published separately and the contract address is returned. A client instance is then created to connect to the local network inside the Docker container. With this approach, manual contract management is eliminated. Each test starts with a fresh contract state, ensuring isolation and reliability. And to make things even easier, the container comes pre-configured with 100% accounts, so you no longer need to handle this step manually. Now, let me show you how Aptos Test Container works through an example. At the moment, Aptos Test Container supports Rust, so I'll demonstrate how to use it in a Rust-based project. As you can see, we have two main folders. The first one is the contract folder, which contains the move code. The contract is based on instructions from the Aptos documentation. It includes two key functions, setMessage and getMessage. SetMessage saves a string message into Aptos, and getMessage retrieves the saved message. The second folder is the source folder, where we write our Rust integration test. We start by adding the Aptos test container package to our calco.tom file, like this. Now let's dive into the test writing process. All the test logic is placed inside a function called run, which is part of the Aptos container test Aptos package. This function takes two parameters: the number of accounts required for the test, a callback function where the test actions will be executed. This setup helps manage the limited number of pre-processed accounts by handling them efficiently within the test. Next, we call the lazy Aptos container function. It checks whether local network is already running. If not, it creates one inside a Docker container. The return value is a global instance of the Aptos container struct, which we use to manage the container. This is especially useful when testing multiple functions without spawning multiple containers. To set up the Aptos client, we retrieve the node URL from the Aptos container instance, and then we call the run new function to initialize the client. The Aptos container also has a method to get the network's chain ID, as shown here. Next, we use the accounts provided by the test setup to get the account's private key. With this, we can create an instance of local account. Once the account is set up, we can upload the contract by calling the upload contract method. This method takes five parameters: the location of the contract folder, the part key of the account used to publish the contract, a hash map containing the package address, an option to support multiple packages, a flag to indicate whether or not to override an already uploaded contract. Now we can start writing our test logic. First, we update the sequence number for the account. Then we build a transaction to set the message of the contract to hello world and submit it to the network. We check the transaction status to confirm it was successful. Finally, we can query the network to retrieve the message using getMessage. At this point, we assert that the retrieved message is equal to hello world, ensuring the contract is functioning as expected. And that wraps up the presentation. If you're interested in exploring Aptos Task Container, the link on the screen will provide everything you need to get started. Thank you for your time and attention.